In this video, we're going to go ahead and take a look at how we can measure the strength of certain relationships with the examples that we've seen in the past couple videos. Now, some of you may have already dealt with the concept in this section, maybe in like a psychology class that you may have taken before. But what we're going to be looking at here is a value that we refer to as the sample linear correlation coefficient. It's just noted by the symbol R. But this symbol right here is going to be of extreme importance for us in this section and the rest of the chapter, because it is going to be a number that is going to help to measure the strength of a linear relationship between two quantitative variables. So this is a value, again, it's only going to help us determine how good of a linear relationship we have. So in order to understand this value a bit better, we can see some of these important data point or bullet points that we have up here. We're always going to be able to compute the value of R if I have paired quantitative data in scatter plots that are, well, roughly linear. I mean, I can still use this otherwise, but it works better if things are roughly linear. R is ultimately going to be a unitless number that exists between -1 to +1. It's not a percentage, but you'll see that I often treat it kind of like a score. The idea here is something kind of like what we see down below. If I have dots that are kind of falling into a positive relationship, like they're going up over time, and I kind of can see maybe a linear path, I'll see that I get a score for R that's pretty close to a +1. Notice it's almost like an 85% if I thought about it as a score, although it's not a percentage. Notice though that as the dots get more and more clumped and clustered and they look more like a straight line, that value is going to get even closer to 1. And if my dots fell perfectly into a straight line, it comes out exactly 1. Notice that the only reason that I would ever use negative values for R is if my data is going to go downward in a downward direction. And again, the closer the dots are to being in a straight line, the closer the value turns to a 1. It just has a negative to indicate it goes down. Notice that I'll get values of R that are very close to 0 if I kind of get just like a splattering of points everywhere, or I get shapes that don't appear to be line-like shapes. So in our class, to try to find the value of R, we're going to be going ahead and doing a test on the calculator. Now, interestingly here, we're not actually trying to use the test to complete a hypothesis at the moment. We're just going to be using this test to find the value of R. That's it. And so we'll see how this works. We're going to be using the lin-reg t-test that should be on everyone's calculator. Now, if I take a look here at example 4, we'll see how I can use this to find the value of R for each of the examples, numbers 1 through 3, that we dealt with earlier. So I'm going to go ahead and pull up my calculator and start to take a look back at example number 1. So if I was to go here and go back to example number 1, this is the graph where I had list number 1 and list number 2 in my calculator. It was the number of hours studied versus the score on the final exam. Now this kind of looked like a linear relationship. And to find the value of R that goes with this, that'll measure how good of a linear relationship this is. I'll click on the stat button, go to tests, and I can scroll up. Then I can go look for lin-reg t-test. Everybody should have it. If I click enter on here, I'm just going to tell the calculator that my x's and y's were in these spots, and I actually don't care about any of the rest of these inputs. I'm just going to go right to calculate, and I'm done. The only thing I'm going to get at the end of this is a whole bunch of info that relates to a hypothesis test, which we'll talk about in 11.4. But for the moment, if I just scroll down on the down arrow, I'll notice that the very last entry here is R, and that's the value that I want to write down. So I'm going to go here and just note that R was given to me there, and I believe, let's see, it was 0.9658. 0.9658. So notice that's a positive value, which means my dots were going up in the picture. And it's also a pretty large value, close to 1, which means that there is probably going to be a very strong linear relationship. Okay, if I was to take a look at example 2, I could repeat the exact same steps. I'm going to go run this hypothesis test, but I'm just going to use list number 3 and list number 4. So if I go ahead and oops, that's not the button I wanted to click. I'm going to use list number 3 and number 4 in this test. I'm going to go right to calculate, and I can see here that if I scroll down, my number is, well, it's a negative number, negative 0.3029. So here I get R is roughly negative 0.3029. Notice that indicates that it's a negative relationship. The dots are generally going down, but this is like a pretty low score. It's pretty close to zero. So this is a very weak decreasing linear relationship. Now we'll take a look at each of these as they compare to their scatter plots in just a moment. Let's take a look at the last one though. So here I would go ahead and I would compute, same thing, lin/reg t-test, but now I'm just going to use list number 5 and list number 6. If I go to calculate, I'm going to pull up these numbers. Scrolling to the bottom, I'm going to get 0.0457. So R here is roughly 0.0457. And so this is a, I guess I'll word it as an almost non-existent linear relationship. So we can take a look at these values and understand how they actually correspond to the pictures that we sketched out previously. Number 3 is actually no surprise. Notice that back on number 3, we pretty much had no line-like relationship whatsoever, so the score is extremely low. On this one, we also got an extremely low score. I might see if I looked at just these data points that maybe there is like a negative-ish relationship, but maybe some of these points seem to fall out of the way, making the score very low. And this one here was a very line-like relationship, and so its R score was very, very high. Ultimately, when we work with these values, my general rule of thumb is that if I see an R score that's like a 0.6 or higher, I'm going to say that it's kind of like a passable linear relationship. It's not great, but it's passable. You can almost kind of think about it like a class grade. The common saying, D's get degrees. Right? So if I get something that's like at a 0.6 level, it's passing. It's kind of good enough. But just because it's good enough doesn't mean that it's a very strong relationship. But if I get anything that tends to be kind of under that 0.6 mark, I tend to start to say that it begins to be a pretty weak relationship. All right, so hopefully this explains to you a little bit about how we use this value of R to describe these scatter diagrams and the strength of the linear relationship present. In the next video, we'll start to take a look at the idea of correlation versus causation.